Hello my dear students, hope all of you are doing well. Let us solve very simple example of resultant of co-planar non-concurrent force system. First of all, this is our data. Now look over here at sign convention. Here this is assumed sign convention, okay? Upward is positive, downward is negative, right side force is positive and left side force is negative. Here we are going to determine magnitude and direction and position of resultant force. Right. Now let us take reference point. Reference point is A. Right. Now we need to resolve forces. Yes or no? Yes. Let us resolve this force 5 kilonewton. Vertical component is 5 sin 30, right? And horizontal component is 5 cos 30. Okay, now forget about this. Okay, now next resolve this. Vertical component is 9 sin 60 and horizontal component is 9 cos 60. Now forget about this. We have already resolved it into two components, right? Remember, this angle is 60 with respect to positive x, and that's why this is cos, right? If this angle is with respect to y, then it is sine, right? Got it or not? Okay, now for this 7 kilonewton, no need to resolve that. Now for this 8 kilonewton, no need to resolve that also, right? Now let us determine magnitude of resultant. What we have to do for the same? We have to resolve all forces in x direction as well as in y direction, right? So summation of all forces in x direction is sigma fx, right? It is minus 5 cos 30 because it is in the left side, so minus 5 cos 30. Where is the another one horizontal force? This is over here, 9 cos 60. Again it is right side, that's why positive, right? Now this 7 kilonewton and that is acting on left side, so it is negative, right? So summation of all horizontal forces is minus 6.83 kilonewton. Now next let us resolve all forces vertically. Right, now sigma F5, summation of all forces in vertical direction. So this force is acting in upward direction, that's why positive. This force is also acting in upward direction, that's why positive. Then this 8 is acting in downward direction, so it is negative, right? So 5 sin 30 plus 9 sin 60 minus 8, right? So it is 2.294 kilonewton. Now resultant is square root of sigma fx square and sigma fy square, and the answer is 7.2 kilonewton, right? Hope you get how we have determined magnitude of resultant, right? Now next is we have to determine direction of resultant. Now for the direction of resultant, what we have to do here, sigma fx is negative and sigma fy is positive, means x is positive and y is negative. So your resultant is in quadrant 2 because x is negative and y is positive. Okay, and this is about the theta. Tan theta is equal to sigma fy upon sigma fx in mode, and the theta is 18.56 degree. Right, so we have determined direction of resultant also. Now what is remaining? Remaining is position of resultant. Let us determine position of resultant. For the same, we have to apply Varigon's theorem. What about the equation of Varigon's theorem? Algebraic sum of moment of all forces about any point that is equal to moment of resultant about the same point. Right, so let us start with sigma mfa, that is the moment of all forces about a point. Starting with this, remember our reference point is a, so we have to take moment of all forces about a point. Now tell me, for this force as well as for this force. Do we have any moment? And the answer is we don't have any moment of these two forces, because the line of action of these two forces is passing through a point only. So we don't have any type of moment for these two forces. Right, now next, for this force, okay, what about the line of action over here, right? And this is 9 cos 60. And what about the moment? Moment is in which direction? Clockwise direction. And what about the perpendicular distance from a point? It is 2 meter. So 9 cos 60 into 2, and the nature of moment is clockwise, and clockwise we are taking positive. So it is 9 cos 60 into 2 clockwise, and it is positive right here. 9 cos 60 into 2 clockwise positive. Right, now for this force. Now tell me, do we have any moment of this force? 9 sin 60, because the line of action of this force is also passing through a point. So we don't have any moment of 9 sin 60, because we don't have any type of perpendicular distance, right? So 9 sin 60 into 0. Okay, so 9 sin 60 into 0 you can see over here. Right, now for this 7 kilonewton, what about the moment of this force? Okay, 7 kilonewton into the perpendicular distance of this 7 kilonewton from a point is 2 meter again. So 7 into 2. See what about the nature of moment? Again, see what about the nature of moment? Nature of moment is, and you are correct, anti-clockwise direction. Right, so 7 into 2, that is 14 in anti-clockwise direction. So minus 7 into 2, because the moment is anti-clockwise. Plus, now for this 8 kilonewton. What about the perpendicular distance from a point? It is 2.5. So 8 into 2.5. Now tell me, what about the nature of moment from end, arrow and clockwise direction? The nature of moment is clockwise. 8 into 2.5 clockwise. Here these two moments shown by blue color, it's clockwise. This one is anti-clockwise, shown by blue, shown by this red color, and this all moments are 0. So algebraic sum of moment of all forces about a point is 15 kilonewton into meter in clockwise direction. Right, now moment of resultant about a point. We know the resultant, but we don't know what about the distance x. So resultant into x. Now you can equate this to 1 and 2, and you can determine x, and that is x is equal to 0.48 meter from a point. Okay, so this is about the position of resultant. So dear students, what we have determined? We have determined resultant of co-planar non-concurrent forces, as well as its direction and its location where it is acting. Right, now if you have any query, any questions, kindly mail me at structurelengineeringconcepts@gmail.com. You can also share your comments, and if you have any query in any type of structural related to structural, you can share me. Okay, thank you for watching. Thank you so much.